Under data structure, the second point is using graph, which is a non-linear graphical representation. A graph is a non-linear data structure which consists of the node and vertex. This graph can be represented in two ways: one by using the adjacency matrix and by using the adjacency list. Matrix is nothing but using an array, that we call it as an adjacency matrix, and by using pointer we can represent the graph that we represented as adjacency list. Adjacency matrix Adjacency matrix is a sequential representation which can be used to represent the node which are adjacent to each other. If there is a edge connect between the node which represented as 1. According to the graph, the matrix is considered by counting the number of nodes. So n into n, which represent the number of nodes in the matrix. If there is any edge which have a link between the vertex I and vertex j, then the corresponding element we represent it as 1. Otherwise, we mark it as 0. If there is any weighted graph present, then instead of representing the 1, we can use that respective weight as the value in the adjacency matrix. The next one is representing the graph, which is nothing the undirected graphical representation. If the edge exists between the node, we mark it as 1. For an example, let consider the graph consists of 5 nodes where a node D consists of the self loop. So, if the A doesn't have any self loop, then the A with A represented as 0. Likewise, for all other vertices, we will be representing B with B, C with C, D with D as 1 and E with E as 0. Apart from D, every diagonal is represented as 0. Let's consider another thing. For an example, let's consider the vertex C and B, which doesn't have any direct representation, so that the value of C with the B and B with the C are marked as 0. Let's consider the third one, B with E, where we have a direct representation B with E, so that the value will be represented as 1. It means that if there is an edge connect between the two vertices, then it will be marked as 1. Otherwise, it will be marked as 0. Directed graph representation. For an example, let's consider there is a direct graph representation. Directed graph representation. For example, let's consider the graph where we have a point from A to B. It means that we can able to travel from A to B, but it is not possible to visit the vertex from B to A. So, according to the directed graph representation, the value of A with 1 will be marked as 1 and the value of B with A will be marked as 0. Likewise, the self loop D with D will be having the value 1. Let's consider the third point, B with C, where we doesn't have any direct representation, so that the C with the B and B with the C will be marked as 0. If there is an edge between D to A, then the matrix will be having D with A as 1 and A with D as 0. So this is a notation to represent the graph in the directed representation as well as by using the undirected graphical representation. It is very simple to represent the graph in matrix format. The next consideration is adjacency list. That means the same matrix, the graph can be represented by using the pointer representation. That is adjacency list. Adjacency list is the linked representation. Instead of representing matrix, we will be using the pointer concept to represent the graph. In this representation, for each vertex in the graph, we maintain a list of its neighbor. It means every vertex of the graph contains a list of adjacency vertices. If an array consists which is indexed by the vertex number and Here it will be represented by using the pointer. So for simplicity, we will be considering the singly linked list. Let's consider the undirected graph representation. So this is by using the directed graph representation using matrix. Here, instead of the value 1, the weight will be represented in the matrix. So according to the undirected weighted graph representation, the value of A with B and B with A will be represented as 7. So in previous case it was mentioned as 1, but here we have an actual value, so the weight will be represented with matrix. And this is the example representation of your linked representation. So let's consider the same graph where we will be using the pointer representation. So let's consider the vertex A. The vertex A is having direct connection between the vertex B, C and D. For an example, here A is not connected with the D, rather the D is connected with A. So we will be maintaining the friendly, we will be maintaining the node which have the direct connection. So A will be connected with B and C. So we maintain a friend list, that is B and C. So A will be connected directly to B. From B it will be connected to C. It's not necessary to follow the same order. Even we can represent A with C and C with B. Let's consider a node will be considered, rather the matrix. Here a node will be considered. We know that a node will be carrying the actual data and pointer to another node. So here according to this example, a node will be considered. So the node A is connected to another node using the pointer. So we know that a node will be having two segments. The second segment represents the pointer, which is nothing. It will be connected to the another node. So if there is no link, then that node will be represented to null. So in our example, the C is not connected. That means the A is not connected with the D and E. So that from C there is no way to represent to C, D and E. So that's why we made the C to null. Let's consider the another node D. Here the D is connected to the vertex A, the C connected to vertex D and D connected to vertex E. So a single vertex, that means a single node D connected with three different nodes. One it is the self and another two different vertex. So here we represent D will be connected to D. From D it will be connected to A. From A it will be connected to E. So that no other way to represent, so that the pointer from E will be set to null. So this is a way of representing your weighted graph. And from E we doesn't have any node to represent, so that node from node E it's set to null. Thank you.